finish up those notes. So what we were looking at is special quadrilaterals. A parallelogram is one of those special quadrilaterals, but all of the rest of the figures that we talked about, which include rectangle, rhombus, and square, are types of parallelograms. So these theorems over here on the left are in fact properties of parallelograms that are true for all of these figures. Which means theorem 5.1, opposite sides are congruent, 5.2, opposite angles are congruent, and 5.3, diagonals bisect each other. Also, by definition, a parallelogram is a quadrilateral with both pairs of opposite sides parallel. So that's one more property that all three of these figures have added to their definition. So a rectangle is a parallelogram with 4 right angles. A rhombus, a parallelogram with 4 equal sides. And a square is a parallelogram that is both a rectangle and a rhombus. I would like you to put your book away, please. Thank you. Okay. Now, theorem 5.12 then gives us some more properties of these figures. Theorem 5.12 is specifically for rectangles. A rectangle has congruent diagonals. Theorem 5.13 gives us another property that's specific to a rhombus. The diagonals of a rhombus are perpendicular. Theorem 5.14 gives us another property that's specific to a rhombus. The diagonals of a rhombus bisect 2 angles of the rhombus. Each of the diagonals bisects the 2 angles that they go into. Theorem 5.15 is where we were when we stopped. The midpoint of the hypotenuse of a right triangle is equidistant from the 3 vertices. And what we have here is a right triangle. If I can move the blue one off, you can see the right triangle. And what the blue one was is the same right triangle cloned and rotated and placed on top. And what that gave us was a rectangle. Since the diagonals are congruent and bisect each other, that point O is the midpoint of both diagonals, and all of those pieces, BO, AO, and CO, must be congruent. And that's where we ended. So we're going to go on to, is it theorem 5.16? That's where we're going to go on to. Theorem 5.16 tells us how you prove that a parallelogram is a rectangle. We know by definition if it has all 4 right angles, then it's a rectangle. But theorem 5.16 says it's enough to show that the parallelogram has one 90-degree angle, and then it must be a rectangle. So theorem 5.16, if an angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So we're going to have a parallelogram. Let's see if I can find the one I want here. We'll call it ABCD. And we're going to be given that this is a parallelogram and that it has one right angle. So we'll say that angle A is a 90-degree angle. What we're going to prove then is that all of the angles are 90, which means this is a rectangle. So we're going to prove that ABCD is a rectangle. What I know, since this is a parallelogram, is that opposite sides are parallel. And I think that's enough. What's that?
Same side interior complementary.
Yes, same side interior angles have to add to 180, so our supplementary. So that would mean if this angle right here is a 90-degree angle, then this would also have to be 90, right?
Wouldn't see.
And opposite angles are congruent, so C has to be 90 and D has to be 90, right? So then this would be a rectangle. So putting this into words then. Since ABCD is a parallelogram, with angle A of 90, and since same side interior angles of parallel lines are supplementary, and opposite angles of a parallelogram are congruent, then angle B would have to be 90, and also angles C and D would have to be 90. Same side interior angles are supplementary. Measured angle C has to equal 90. Also, opposite angles of a parallelogram are congruent. So measured angle B, D, A, and C will all have to be 90.
Meaning that ABCD is vertical.
Therefore, ABCD is a rectangle. Yes. Our last theorem here is theorem 517, which tells us how you prove that a parallelogram is a rhombus. We know by definition, if you can say that all the sides are equal in the parallelogram, then it is a rhombus. All four sides equal. Theorem 517 says it's enough to show that just two of the consecutive sides are equal, and then it is a rhombus. If two consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. Up with our parallelogram figure that we want. We're going to be given that ABCD is a parallelogram and that two of the consecutive sides are congruent. What does it mean for sides to be consecutive? One right beside the other. They share a vertex actually, right? That would be consecutive sides. So here we have AB equal to BC. What we're going to prove then is that means that all four sides have to be equal, so therefore this is a rhombus. So we're going to prove that parallelogram ABCD is a rhombus. What we know about a parallelogram is that opposite sides are congruent. So we pretty much have our proof just from that statement. Since opposite sides of a parallelogram are congruent,
That means BC is equal to 80.
exactly,
And BC is equal to 80.
exactly. So from the given, then all four sides are equal. Which is AB equals BC equals CD equals AD. Which means ABCD is a rhombus by definition. All right. That was our last